In Renewable Energy Technology Laboratory, we are going to see the experiment on simulation study on intelligent controllers for hybrid system. As in the previous experiment, we have seen what is meant by hybrid power generation. That is, two or more sources combined together to generate the power. So here I will be considering the solar and wind power as a hybrid system. So wind and solar combine and make a hybrid system. And here the intelligent controller is used to maximize the output power. So the aim of the experiment is to simulate the to perform simulation of intelligent controllers for a standalone hybrid generation system using a MATLAB software. So this is an hybrid power generation with MPPT control, that is maximum power point tracking. So that here the maximum power point tracking can be used to where the maximum power at the point where the maximum power can be generated by using the in the hybrid power generation, that is by using the solar and wind power generation. So once again the hybrid and wind and solar has been used. Here the boost converter has been used, and for the boost converter, by using an MPPT algorithm, the gate pulses have been given to the boost converter so that the maximum power generation will be occurring. So once again the output is given to the inverter, and the inverter output is given to the load where the voltage and current can be analyzed. So in MATLAB, so this is an hybrid power generation control with a MPPT control, which I have designed previously. Here the solar and wind turbine, solar and wind has been used. The irradiation is given as input, and here for wind, the wind speed has given as input. And here we are using an MPPT algorithm where the voltage and current has been taken from the turbine, and it is given an initial duty cycle has been given, and the saturation through pulse generator. The pulses have been given to the boost converter. Similarly, in for solar also, and the boost converter output is given to the inverter, and the inverter output is given to the load. So each parameter name can be seen here by clicking it. So this is an IGBT, and the parameters of IGBT has been listed here. Similarly, I have an scope where I can see the output of the solar. Solar can be seen separately and wind can be seen separately. And by combining both solar and wind, how the both the sources combine and supply the power to the load. So here, once the design has been completed, I will be running the experiment, and you can see here it is compiling. If there is an error, it will show error. Otherwise, the compiling will be completed. Once the compiling has been completed, we can see the output voltage and current and voltage power characteristics of the solar panel, and we can see the how the voltage has been varying for the load. The load side voltage and current can be noted in this scope. Similarly, the output voltage of the solar and wind can be noted in this scope. Similar, then the combined voltage, DC output voltage of wind power generation, that is 15,500 watt, can be seen in this window. So once the simulation has been completed, we can get the complete output of the wind power generation by using an MPPT algorithm, that is the maximum power point tracking for maximum power output, so that the efficiency will be increased automatically, and the characteristics can be analyzed.